everybody, it's Monty, it's Shadle Park, it's Geometry, and we're in Semester 2, Module 3, Topic 1. We're into dilate and similar triangles, where the angles all stay the same, but the actual measurements have to stay in proportion. So that's what we were doing last time. We were dilating similar figures. Now we're going to go into triangles. Here we go. Okay, corresponding parts. Remember that? The CPCTC, right hand to right hand, left hand to left hand. Let's see what we got here. Okay, enter the similarity between the two triangles. Corresponding parts. Okay, in the similarity, the points that correspond to each other appear in the same order. Okay, so now triangle GZ are similar. The length of GR is 8 centimeters. The length of segment ZR is 5 centimeters. The length of AM is 40. What is the length of segment WM? WM. 8 goes to 40 as 5 goes to. So what are we multiplying 8 times to get 40? 5. 5 times 8 is 40. So what's 5 times 5? 25. All right. Enter the similarity statement. So we're going to go GZR, capital GZR, enter, and AWM, enter. Okay, so we're happy. Use the diagram to determine the lengths. Select a segment and enter the corresponding. Okay, so we're going to click here. GZ in triangle GZR corresponds to GZ, AW, right? AW in triangle AWM. Cool. Select WM and enter the measure. WM, enter the measure. Okay, now we can do step by step. So the solver. Okay. So step by step, solver, hint, use the solver to complete the next step. The solver is available in the header. So the solver button, right? So let's just try that so you've seen it once, okay? Now enter, find an expression to rewrite or an equation to solve. Okay, so we want to go 8 divided by 40 equals, big arrow, equals 5 over x. Submit. Okay, so we want to rewrite the fraction, multiply both sides, and we're going to multiply both sides times 5. Okay, multiply both sides times x, and x is 25. Cool. You're ready to exit. Let's go to a problem. So everything is proportions, right? Everything is in proportions. I wonder if I should have pulled up my smartboard here. Okay, so now the similarity statement, they gave it to us. QLG, see right here, QLG is equal to JRW. JRW. Check it. Okay, now we want to find JR. Okay, so we want to find this. 8 shrinks to a 2. What's the factor? What's the scale factor from 8 to 2? 4. 2 times 4 is 8. Alright? So if it's a 4-to-1 ratio and this was a 4, this has to be a 1. Okay? And we have a solver if we need it. So let's just click on solver and we go 8 goes to the 2 as 4 goes to x. Okay? Alright. So now we want to multiply both sides times x. Okay. Now we want to divide both sides by 4. Divide both sides by 4. And x is 1. Okay? 1. Cool. So hopefully that was helpful using the solver tool and proportions. Okay? Alright. So IBL goes to XZL. Okay? Check it. Now IBL. We want XZ. We want this one down here. So this goes to this. 742. 7 to 42. Yeah. 7 to 42 is a factor of 6. So the answer is going to be 60, isn't it? Okay. So we want this guy here. IB in IBL corresponds to XZ in the big triangle. Okay? Alright? Use a diagram length of XZ. Okay? So the measure of XZ, we can use our solver if we want. 42 is to 7 as x is to 10. Okay, so we're going to multiply both sides by 10. Boom. X is 60. Cool. Rock and roll is here to stay. Uh-oh. Locked up for a second, didn't it? And when this pulls up, we could use our smart board to help us, okay? Not yet? Okay, so now architecture. Enter the similarity triangles. Heather's an architect, aerial photos, museum, skylight in the corners. Two sides of the building have 41 and 49. The length of HQ, the skylight is 17. What is HG? HG. So the whole thing is 49 to this. 41 goes to 17. So GQH. So we go GQH. We're going to go GID. Okay? Ooh, flying palm trees. Use the HG. We want HG right there. Okay? So here we go. Okay, so now let's pull this over here. And we could just do this math, couldn't we? Okay, so let's clear the mechanism here. Clear the canvas. And not registering in my, okay, so let's try this freehand, okay? So we got this big guy, and we have the little guy, right? Okay, so we have the 41 goes to 17.1 as 4904. apologize there. I'm not getting my pen to work, so I'll have to work on that. Goes to X. Okay? So let's get our solver tool out. And what are we looking for? Uh-oh. I'll come back and finish this in a little while. Thanks.